uh, mulai lagi acara seminar ini dan alhamdulillah sudah kenyang, biasanya terus ngantuk ya. Kita sudah kedatangan pembicara yang kedua, Profesor Miroslav Skimniski atau biasa dipanggil Mirek. I would like to introduce you in bahasa Indonesia. Jadi Profesor Miroslav Skimniski ini dari Polandia asalnya, ya. Kemudian ke Amerika, PhD di sana, kemudian jadi profesor di sana, yaitu tempatnya di Purdue University, tempat saya dan Ibu Reni sekolah di sana. Kebetulan saya menjadi mahasiswanya S3 waktu itu, mencoba menilai sejauh mana internet bisa digunakan oleh konstruksi. Jadi waktu itu internet sedang mau mulai booming, sekitar tahun 96-97 gitu. Profesor Mirek ini keahliannya adalah automation and construction. Bahkan sekarang ini, sampai sekarang masih memegang yang namanya jurnal automation and construction. Dan jurnalnya sangat-sangat punya impact factor yang tinggi. Ya, impact factor yang tinggi artinya banyak yang memasukkan papernya ke sana, kemudian papernya di-cite atau disitasi juga ya, oleh banyak paper yang lain. Jadi kalau mau bicarakan tentang automation construction, ada paper-papernya ya, tempatnya ya di situ, nggak ada lagi yang lain begitu. Nanti mungkin bisa diceritakan. Nah, sebenarnya banyak materinya dari profesor ini tentang automation construction. Mau milih yang mana? Jadi bingung begitu ya kalau kita bicara construction 4.0. Tapi kita pilih 3D printing technology. Tapi kalau nanti misalnya mau ada pertanyaan-pertanyaan yang bukan terkait dengan 3D printing pun welcome. So I told the audience that maybe you have other information about other technology and automation and construction that they may ask you. Oke, jadi seperti itu. Kita rencananya begini, setelah nanti presentasi, kemudian kita sama ada sesi diskusinya. Nanti diskusinya ini akan kita undang, ada dari PTPP ini Pak Rahman ya, Pak Rahman Arif sudah hadir di sini. Terima kasih atas kehadirannya. Yang kebetulan menjadi implementator juga ya dari misalnya BIM gitu ya. Kemudian ERP, kemudian 3D printing juga ya. Sudah mulai coba. Jadi nanti kita akan coba lihat, kebetulan judulnya akan disampaikan terkait dengan apa faktor suksesnya dari implementasi 3D printing. So, Profesor Mirek, your time.
Thank you. Is this a remote control? Could we adjust the focus a little bit better? Good afternoon, everyone. I apologize that I'm a latecomer to the symposium this morning, but I just flew in from Singapore about half an hour, almost an hour ago now. And I'm only staying in Indonesia for one day. Tomorrow I have to go back to Singapore. And then on Friday night I fly back to the US. It's just a very short trip and short visit, but it's not my first time in ITB. In fact, this is the third time already. I've been a regular visitor. Unfortunately, the time intervals between the visits are rather long, maybe 5-6 years or so, and I'm delighted to be back. Campus is growing, and under new leadership right now, Professor Reni Virahadikusuma, I still remember how to pronounce her name, and of course Professor Muhammad Abdu are my pride and joy, both of them from Purdue, both PhDs, degree holders from Purdue. And now I've been at Maryland for 15 years, so I have wonderful memories from having both of them as PhD students at Purdue. So my talk today is going to be about one of the key technologies of Construction 4.0. And before I forget, I also want to announce that a new book titled Construction 4.0 is forthcoming in English. It's going to be published next month out of CRC, in the US. And as soon as I have an electronic copy available, I'm going to send it to Professor Abdu so he can then distribute it among you. So that's the topic for today, but if there are other technologies that are of interest to you, I'd be very happy to talk about them as well. So this is the outline of the presentation. I first want to talk about 3D printing technology in general, what it is, and what are the potential applications and some of the prototypical applications that already exist in the construction industry. But I also want to spend a few moments to talk about an ongoing research that my research group at the University of Maryland, in collaboration with Hong Kong University of Science and Technology and a few institutions throughout the US and in Europe, are conducting. Maybe if there are some of you that are interested in the technology and the collaboration, I'll be very happy to also include you in this effort. The whole technology dates back to 1983, and there was a mechanical engineer by the name of Charles Hall, who used to work for Boeing and then General Motors and a couple of other companies, formed a theory of 3D printing. And of course the concept is based on printing in 2 dimensions. Everybody's familiar with things that you can print on paper. If you add the 3rd dimension, you can come up with almost any product from almost any material nowadays. Ceramics, pulverized metals, all sorts of plastic materials, composites, and so on. So that's the initial application. So this is a very rough definition. Some people who are really deep experts in the technology say that 3D printing is not the same as additive manufacturing. But for all practical purposes, for practices of this presentation, I'm going to use both terms interchangeably. So it's a process of joining materials, any material that would be applicable to this process, usually layer upon layer, although not exclusively. And you can make objects from 3D model data directly. So that's the definition. If we fast forward to 1998, a colleague of mine from University of Southern California, Professor Bero Koshnevis, originally from Iran, he started a new concept in construction called contour crafting. Contour crafting is application of the idea of 3D printing to forming walls made of cementitious pastes. So cementitious paste. He's credited widely with being the first pioneer of the additive manufacturing in the construction industry. So these are some of the techniques that are being used for construction applications of 3D printing. One technique is powder-based, so it's not layer upon layer. It's really dispensing a pulverized material, typically bound together by some form of some kind of resin, either natural or artificial resin, usually engineered resin, that can generate any kind of shape that the architect can possibly dream of. So fantastic shapes, highly irregular, that would be almost impossible to form using conventional formwork if you wanted to do it in concrete. But the most popular techniques are not really powder-based for construction applications. Most techniques are based on extrusion technology. If you are familiar with injection molding, which is really the most popular plastic product manufacturing technology anywhere in the world, it's almost an equivalent of it with some modifications, but with application to a cementitious paste. That cementitious paste, of course, needs to withhold significant forces, both vertical and horizontal, depending on the nature of the design. So there is this question of reinforcement. How do you reinforce this cementitious paste? And the easiest answer to the question is use fiber reinforcement. Dozens of different types of fibers have been tried successfully and implemented with 3D printing applications of this cementitious paste. But you can also classify 3D printing applications in construction based on the type of material that is being used. So the one that's most popular is still cementitious paste. So it's really cement mixed with sand and some sort of other aggregate. Could be natural, could be artificial aggregate. And of course reinforcement, either fiber or conventional reinforcement that is being applied. But you can also use other materials. University of Maryland Materials Science Department has recently patented a product that's called liquid wood. And it's really a sort of like a pudding type of material that you can fill into forms. And when it settles, it has the look and feel and even mechanical behavior of wood. It could be engineered to look and feel and even smell like oak, like pine, like even some of the exotic woods, or maybe exotic for us, but not for you. Exotic woods that are normally very expensive and very difficult to attain. For example, bamboo. Bamboo, of course, here it's a weed, and it's ubiquitous. It's pervasive. Whereas in the northern hemisphere, especially above the, maybe 60th degree latitude, it's not so common. However, this material has not been used for 3D printing just yet. There are some initial experiments to see whether it'll be applicable in the construction of some non-load-bearing components, maybe furniture, maybe something else that will be applied. Also, a common material is foam. Rapidly expanding foamy compounds that are being used as fillers for example, for plastic forms or metallic forms where insulation is required. Some of these foamy materials, when they settle, they're quite hard and they can carry significant compression forces. Some of them even work well for bending loads, so bending moments. But there is still a lot of research and development going on the topic of durability of these materials, their dexterity, and their load-bearing capacity. We don't have much data on that because it's such a new technology. So there are big questions that remain unanswered as to whether this material will meet the requirements of safety codes, for example, structural safety codes or building codes. Nevertheless, experimentation is ongoing because 3D printing, additive manufacturing, construction is considered as one of the most promising technologies within the context of Construction 4.0. So another way to classify this this equipment, this technology is by what kind of equipment is being used. The most popular equipment for 3D printing applications in building construction are gantry systems. Gantries that can be set up relatively quickly and dismantled quickly as well. And they can carry significantly sized manipulator arms that can perform structural and non-structural assembly functions from overhead. And that's the technology that's used by contour crafting by this company, started by Professor Kośniewicz in Los Angeles. He's actually on a 2-year leave of absence from USC, making sure that the company grows, that it delivers on contracts that it has already signed with some housing developers in the LA area. Another technology are just robotic arms placed on mobile platforms, either tracked locomotion, or some of them are wheeled locomotion, and some of the most unusual applications that there's even legged locomotion for some of these. I don't have a slide in this deck of slides, but anybody interested, I have another presentation on construction robotics. If we have, depending on how much time we have today, I can show some of that as well. And there are also cable suspended systems. They're championed by Italian architects, especially an architectural firm of a professor from Milan Polytechnic, Politecnico di Milano in Milan, Italy, in northeastern Italy. Enrico Dini, and his company is now famous for producing circular buildings using foamy materials that harden very fast, and they appear to be quite durable. Nobody knows exactly, nobody has done rheological studies on them to see whether they're going to last beyond, let's say, a period of 10 or 20 years. Nevertheless, some simulation studies based on basic properties of these materials have shown that they're likely to be as durable as traditional concrete structures. Time will show whether that's actually the case. Now, having said that, I must also say that there are a lot of developments in the field of nanotechnology for nanocoatings of construction materials. The big concern is what is the impact of nanocoatings on construction for constructed facilities in terms of their impact on the environment. Nobody knows that for sure, whether nanocoatings are going to be good, bad, or indifferent for the environment. Perhaps this is one of those areas where someone at ITB can take upon himself or herself and see whether that can be developed into some body of knowledge. And there are also applications, relatively small mobile robots that can move around the construction site and actually just deliver of construction projects using 3D printing technology. And maybe the most exotic application are swarms of micro robots that can behave like insects, maybe like termites building their hives. There were some experiments, physical simulations done out of Harvard University School of Design that have shown that these very small robots, micro robots, do not really require sophisticated control systems. They just follow the leader. If the leader can initiate a certain task, other robots in the swarm can just add on, and then others can be pre-programmed to actually just follow the predecessor. And when you look at how insects are building their homes, their hives, this is the kind of behavior that they follow. So the research team that consisted of mechanical and electrical engineers designing these micro robots also included entomologists, and these are specialists in insects, and they were particularly interested in the legged locomotion that insects show. The most prolific insect when it comes to survivability is actually a cockroach. And cockroaches can survive a nuclear attack, and there are some predictions that if, God forbid, the world is ever inflicted upon by a nuclear catastrophe, the only survivors would be cockroaches. I hope it'll never happen, but nevertheless, the study of cockroaches shows that they have the most resilient locomotion system of any known creature on Earth. They can lose half of their legs and still run just as fast as they normally do, and they can move in every direction. And so, question is, can we actually learn a lesson? This is called biologically inspired design. We don't have to reinvent the wheel, so to speak. We don't have to come up with our own solutions. If we can just observe closely enough and carefully enough the various animals, especially insects, and try to mimic the design that is backed up by thousands, if not millions of years of evolution that these insects benefit from. So anyway, these are the various ways to classify 3D printing applications. And why am I saying all these things about robotics? Because 3D printing technology cannot really exist and be implemented in the construction industry without robots. So robotic technology is essential in the application of 3D printing in construction. So as far as the size of the objects that these robotic devices can print, they're still relatively small, but there are some experiments like Grammatio and Color at ETH in Switzerland. They can build retaining walls of very irregular shapes using traditional reinforcement mesh, perhaps, or that reinforcement can also be created from a welding compound by robots. I'm going to show you later how this is being done. Or you can develop very irregular and odd-looking. Any idea what this might be? This is actually a structural connection. This is a beam-to-column connection that was developed based on a computer simulation to minimize the stress concentrations under certain design load conditions. And this would be impossible to fabricate with any conventional fabrication technique other than 3D printing. So 3D printing, 5 minutes left. That's it? Okay. So maybe the time constraint can be relaxed because I have too much to say. Okay. So the other objects that can be constructed are ornamental columns like this using 3D printing, or small houses like this. These houses are still being developed on an experimental basis, but they are in fact quite a promise. Let me show you the next slide. This is a project that was initiated in 2018 in Austin, Texas. Two graduates of University of Texas at Austin, one an architect and one a civil engineer, decided to produce this 3D printed home, very small, only 60 square meters, and the time of production, so it took them 47 hours actually to print these walls, all right, using cement-based paste and an overhead gantry that had suspended manipulators that were performing the 3D printing, and the entire structure was printed. The only thing that was not printed were these roof joists. They're actually wood, so the roof was actually placed on top of that. But look at how this interior actually turned out to be. They left the walls using just raw concrete, and they decorated this little home. And this is just a showpiece for what this technology can do. It's on a construction exhibit in Austin, Texas. The company name that's doing this is Icon Build. You can go to this website and see for yourself what other products they're interested in. And so this is just one example. Here's another one. 2.5 years ago in Nau, in northern France. 95 square meter building. The material used is polymer with inner layer of concrete and a robotic arm. So a robotic arm that you can see here was used for the delivery of the materials. So the entire structure was actually printed. Here's another project a year and a half ago in Milan, Italy. This is also a spin-off company from some research that was done at Politecnico di Milan. And it's a cement-based paste material, a robotic arm to deliver this project. And only structural components were produced in this technology, and they were assembled together on the project site. And the reason is that because this is a larger product, 100 square meters, so applying a gantry system to produce the whole house would have been feasible. Nevertheless, they wanted to do it faster. That's why they decided to put it in pieces. And a robotic manipulator was used from a mobile robotic platform. Now, even some furniture and some so there is a manufacturer in Italy that is printing bathtubs of fantastic shapes that are difficult to attain with conventional technologies. You can also print tables, and you can print other permanent fixtures in the building, so that is also quite possible. Yet another company, and this was only less than a year ago, like 6 months ago, in Poland, an experiment to build just a single room, very small, 7 square meters, cement-based material, and it was a gantry robot that produced that. The idea is to be able to print 3D modules, for volumetric construction, and to be able to assemble them, either stack them up or put them one next to the other for various configurations. There is quite a bit of promise in relation to 3D printing in modular construction. There is another company in Poland, just outside of Kraków, that is designing and producing modules for the tallest ever modular hotel building in the world. And the interesting thing is that the modules are being produced in Poland, and they're being shipped along Vistula River to the Baltic Sea, put on barges across the Atlantic to New York City, because the hotel is being built. It's a 58-story hotel on 6th Avenue in New York City, the tallest ever modular building to be built. And some of the components in those modules are actually 3D printed. Not the structural bearing, not the load-bearing components. Nevertheless, some decorative components are being included in there. This is a company out of the Netherlands that is printing a steel bridge, a pedestrian bridge, using pulverized steel material. So this project it was under experimental stages. You could see the load test of people jumping on it. This is now not the first. In fact, there is 7 or 8 such bridges throughout the Netherlands, and there are others. So you see the components being transported directly to the installation site. These are relatively small bridges. Last October, I participated in a conference on 3D printing and construction, which was in the city of Nanjing in China. Just outside of the city of Nanjing is Hebei University of Technology. They have, during the conference, they installed a 28-meter span bridge for pedestrian use on the campus of that university. And it was produced in segments in the university laboratory and delivered to the installation site directly on the project site. So China is actually a big proponent and a big practitioner of 3D printing and construction. There are several companies that are turning out products very quickly, and in fact already contracting with major government organizations in China and throughout the world. The municipal government of Dubai in the United Arab Emirates has ordered about 300 of modular bus stations, and this is rather than, it's not a bus station, it's a bus stop, but fully air conditioned, with all the installation as inside, a luxury bus where you sit down. And the reason is that if you're in Dubai or in Abu Dhabi in the summer, the temperature can be above 50 degrees Celsius. Nobody would want to stand and wait for a bus under those scorching heat conditions. So this is a market that they're trying to exploit. During the lunch break, I was talking with some of you about what's happening in Singapore at the National University of Singapore. They in July of 2018 they had a workshop on application of cementitious paste to construction 3D printing, and they produced a design and a prototype of a toilet, an outdoor toilet for rural areas in India. Where public health, well, actually sanitation is a huge public health problem. And Asian Development Bank, together with the Indian government, Ministry of Health, are interested in actually seeing this kind of toilet mass produced. Right now it's only a prototype. There is a company in Singapore that is negotiating with the ADB and with the Indian government to see how many of these products they can be delivered and how quickly. The company name in Singapore is Hamilton Labs. In fact, I was in a meeting with some Ministry of Construction officials in Singapore, and they're very supportive and very interested in 3D printing technology and what it can do for industrialized construction methods as an addition to traditional prefabrication. Another company that is producing buildings in China is Winsun Corporation. Winsun is based in Shanghai. The biggest operations are actually in Shenzhen, just across the border from Hong Kong. And they're in the business of producing luxury villas like this. Some of these villas may be as big as 600 or 700 square meters on 2 stories. And they're modular, so the modules are produced in the factory, 3D printed and brought in for installation directly on the project site. But they also produce these very small houses, single room or double room houses, mass produced for rural as well as suburban markets, markets of large Chinese cities. And you know, China has almost 1.45 billion people and about 300 cities that are 2 million people and above. And so there is a dire need of producing more housing, affordable housing, in the outskirts of these cities, because China now has a surplus of housing that's produced for the speculation market. Nobody knows what's going to happen when the bubble bursts, but they were built by using conventional means. The prices have sort of leveled, but they've been going up like crazy for a number of years. Question is, what can be done in order to be able to house people who cannot afford these high prices in high-priced residential neighborhoods in major Chinese cities? So this is what's happening right now. Other interesting applications include artificial reefs, and you wonder what this is for. They can be, you know, there is a lot of soil erosion and erosion of beaches in various countries, and the marine life is suffering as a result. So being able to actually mass produce these artificial reefs and dump them off the coasts of major tourist areas may actually help restore some of that marine life. But also, there is a strong interest in these artificial reefs from from those establishments that are engaged in industrial production of fish and various seafoods that are being sent to the mass market for consumption. So all of that is of interest. These are some ongoing projects in Russia. This company has made a name for itself, IPTEK. They're based in Moscow, but they are designing small buildings for deployment in Arctic markets, where temperatures can be as low as -40 and sometimes -45 degrees. So almost impossible to do any real work outside under those temperatures. And there is enough of an achievement in plasticizer technology that concrete actually can be placed, can be printed in temperatures down to about -20 degrees. They haven't tried anything below -20 degrees, but using plasticizers going down to -20 is what they're experimenting with at this point. So there will be a lot of new research and development in relation to how do you place reinforcement steel in these 3D printed structures in order to be able to meet the code requirements as far as load-bearing capacity is concerned. This is still ongoing work. I had another meeting with a Dutch company that's located in Singapore, that is doing this work in conjunction with two different universities in Singapore that is trying to produce conventional reinforcement using 3D printing techniques at the same time as concrete material is being laid through the extrusion process. So that's quite interesting. There are some patents on the way as to how this is going to be accomplished, and probably we'll stay tuned for the next 2-3 years. This technique will probably find its way into industrial applications. So all these buildings that you can see here were actually produced using 3D printing technology. Okay, what's driving the business is not just terrestrial construction, but also extraterrestrial. NASA in the United States has written out the competition for architects. There were prizes already awarded on how to design and construct a permanent settlement on the surface of the moon for about 200 people. And these people are going to stay there on a rotational basis for 3 months at a time. And it's not just men in their spacesuits. It's going to be families, husbands and wives, and even small children. Imagine sending your family to the moon for 3 months. And where are your kids going to go to school? Where will you go out for a date, and where will you have your meal in the restaurant? So all these issues need to be addressed before any sort of permanent settlement can be established. But some of the winners include architects from major architectural design consulting firms in the US. So this is not just child's play, it's not just university research. It's already gradually but surely moving into the industrial realm. The reason why 3D printing is very attractive for extraterrestrial construction is that there is really no other way to build anything outside of the Earth. And also, if you want to build something on the moon, it has to be done with native materials. So if you want to use concrete on the moon, you'd better develop concrete that doesn't require any water, because there is no water on the moon. So there are actually 3 competing designs of concrete mix that doesn't require any water. So those are already available, so that's not an issue. The issue is how to use the native material, which is the regolith dust, and the rock material that is the regolith that contains an isotope of helium, helium-3, helium of course being a noble gas. Also happens to be a catalyst for a highly exothermic reaction that can one day, not anytime soon, but one day provide an alternative to nuclear power for clean energy. Okay, zero emissions energy. There was a great excitement about regolith. I remember about 35 years ago, when it was first discovered what regolith can actually do, and even brought on onto Earth in cargo bins of Space Shuttle Columbia, it could deliver, if properly implemented in a specially designed power plant on Earth, it could power the city of New York for a year. Just one cargo load of Space Shuttle Columbia. It never happened because at that time, even as the technology was being developed, U.S. Congress, which funds NASA, put a requirement that the 2/3 of the funding for this whole venture would have to come from venture capital. And venture capitalists, they did their risk analysis and they decided that it was too much risk and they were not going to foot the bill. And I think, if I remember correctly, 35 years ago, it was estimated at approximately $200 billion, $200 billion US dollars. And 1/3 would be provided by the federal government, and the 2/3 was supposed to be raised by venture capital. Never happened. But the excitement is high enough that the largest construction company at that time, Bechtel Corporation, has formed a lunar construction division that was getting ready to implement that project. 3D printing didn't exist at the time, but I remember that lunar construction division was headed by a Purdue civil engineer. His name was Ox van Hoften, and after having worked as a civil engineer for a while, he joined the U.S. Air Force, became a pilot, and then was recruited by NASA to be an astronaut. So he was a former astronaut that headed that division. The division existed only for about 3 years. Then it was dissolved because it was clear that the funding wasn't forthcoming. Venture capitalists not being able to fund it, or not wanting to fund it. So the technology is still there. Whether it'll be resurrected now with the ascent of 3D printing remains to be seen, because if regolith is the only material, there are still some technological challenges that that have to be overcome. For example, one of the dangers of living on the moon is cosmic radiation. It's lethal, and all these structures would have to be buried underground, or at least partially underground, and regolith may or may not provide enough of a shield. And it would be next to impossible to use any material that would be brought to the moon from Earth purely for economic reasons. It costs about $3 million per kilogram to ship anything from Earth to the moon. Therefore, it will be cost prohibitive. So that technology is still not mature, and it needs to be developed further. All right, so these are some of the winning designs of how these lunar permanent settlements are supposed to look like. So it doesn't, it's not yet finished. In fact, many of these technologies that are being developed for lunar applications, or maybe ultimately even for Mars settlement, are most likely to find applications here on Earth, rather than being applied on Moon or on Mars. So, switching gears, we have looked at the various technologies available. We have done a lot of research on what's really applicable, what's realistic in terms of what we can apply today. And we want to see how successful these 3D printing technologies can be in today's construction market. How successful they can be within the framework of course Construction 4.0 that relies heavily on sensing technology, on big data, on processing a lot of data and information, and on robotic technology as a core automation technology. So we wanted to embark on a study of technology diffusion from space industry, from military industries, defense applications, into the civilian construction industry. And we wanted to see what kinds of theories are available to model the technology transfer process. And there are quite a few that we investigated, and this is just 5 of them that are listed here. And each of those theories dwells on various implementation factors that make it or break it for the technology transfer process in terms of success or failure of that process. So some of these factors are listed here based on the theories, but we wanted to see how applicable these theories are with respect to 3D printing. And so in terms of 3D printing, out of these 5 theories, and actually even more than 5, we came up with this list of 9 different factors that really matter as to whether this technology will be successful or not. So relative advantage over other techniques is one of them. Complexity of this technology, how complex or how easy it is to use. Trialability, can we try it on a smaller project, see if it works, and can we scale up to a larger implementation? Compatibility is hugely important in construction because we have these traditional construction systems. We call them legacy systems. How well can 3D printing work with existing systems, and can it complement the existing systems, or you'd have to abandon everything and start implementing this technology from scratch. Absorptive capacity is another term that is used by these technology diffusion theories. In our case, that simply means that the 3D printing technology is very likely to absorb the need for more robotization, so more application of robotics technologies in the construction industry, and also material science achievements. Currently, if you look at the funding picture in research and development of 3D printing for construction, about 80% of the funding goes into materials, research and materials testing. There is even a separate symposium in the United States on construction materials for 3D printing. The last symposium was last year in May in Chicago, and this is likely to be a biennial symposium for now, and then eventually it may even happen every year. So there's so much interest and so much research and development going on in 3D printing technologies. There's also an issue of external pressure. Is this a positive pressure or negative pressure? A positive pressure is the need for extraterrestrial construction, various government bodies being interested in it. So that provides impetus for the development of some of these technologies that will be eventually implemented on Earth as well. But there are also negative pressures. Contractors who operate on a low profit margin principle, and their idea of research is, where is my next project coming from? They're not really interested in anything that's technology related. They think that somebody else should do it for them. And they don't even want to be the first to try. They don't want to be a guinea pig. They would like for someone else to show them that it's really going to be profitable, it's worth jumping into. Contractors are not known for their risk, for being able to embrace high levels of risk, simply because if they don't make a profit on a couple of projects in a row, their very existence of their business would be jeopardized. Then there is also this issue of uncertainty. Don't confuse uncertainty with risk. Risk can be quantified and can be managed. Uncertainty cannot. There are various attempts of modeling uncertainty and how uncertainty should be handled, by the fundamental difference between these two is that risk is quantifiable, uncertainty is not. At least no one has really come up with a credible idea to quantify uncertainty. So there are many, many different issues that fall into the category of uncertainty. Will this technology in this complex world be compatible with many other needs of the society? Will the society be ready? Will the industry be ready for this implementation? There are many examples of technologies that were brilliant on their own face that have been ultimately abandoned for a variety of reasons. Maybe people just weren't ready to absorb that technology because they're settled in the ways that things are being done for project management. Anybody who's maybe over 30 years old probably remembers a decade and a half ago, Google had this brilliant project called Google Wave. Does anybody remember Google Wave? Google Wave was supposed to be a revolution on how we handle data and information, how we collaborate together in real time, in many dimensions. How do we collaborate using voice, using written commands? How do we collaborate using pictures, still pictures, motion pictures, 2 dimensions, 3 dimensions, 4 dimensions, and so on? And ultimately the project was abandoned because the society just wasn't ready for it. Maybe a more familiar example would be something that happened just 3 years ago. Anybody remembers Google Glass? Okay, what that was about, right? It was a brilliant technology, and this was not a technological problem to be able to implement it. Why did it fail? Well, it was mostly lawyers, legal problems. This technology allowed you to make a digital record of everything that goes on. I could be wearing my glasses right now and recording everybody and everything at any place at any time. And lawyers said no. Without being given explicit permission, you're not supposed to do that. So Google pulled the plug on the technology, and so however brilliant it might have been, the society is not ready for it yet. And then the issue is that this is probably not an exhaustive list of these of these components. So we have supply side benefits and demand side benefit. This is what happened. We came up with various aspects related to each of those components. We studied them carefully, and we decided that for each particular application of 3D printing technology to a construction project, all of them have to be carefully considered by planners, by technology planners, by business vendors, by project owners, contractors, and everybody involved. So I don't think I have the time to go through the detail of each and every one of them, but I just want to show you that there are indeed quite a few of these to talk about. All right, so in that case, this is our initial model that we came up with at the University of Maryland, and we're now in the process of coding that model into a decision support system. And so if I get another invitation from Professor Abdu, maybe for the next symposium, I'm going to present on the prototype of the decision support system for 3D printing applications in construction. I think I should stop here and see if there are any questions, that I can take any questions, and we can discuss some more on the issues that are of particular interest to you.
So, I would like to introduce you. I think you already met him, right?
Yes, of
From
course,
the contractor. Yeah, already trying to implement the 3D printing. And also Ibu Dewi. Ibu Dewi is our pioneer here at ITP to implement BIM for ITP. Yeah.
Excellent.
So,
Very nice to meet you.
I would like also to invite Pak Haji. Pak Haji will provocate you all to discuss. I think, yeah. Pak Haji.
Ya, thank you Pak Adu. Assalamualaikum warahmatullahi wabarakatuh. Saya Ahmad Suraji dari Universitas Andalas Padang. Bapak sekalian, I think with thanks to Professor Mirex, you already show us how advanced actually the construction industry outside there, gitu ya. But this morning we have talked about our construction industry today, and we still have many fundamental problems. Baik, Bapak sekalian, Pak Abdu mohon izin, ini kita di jam 2.27 di jam saya, Pak Krishna. Kalau diizinkan nanti barangkali bisa mundur jam, menurut schedule ini kita harus closing jam 15.30 Pak. Tapi kalau boleh nanti agak mundur sedikit kalau dimungkinkan. Dan pada kesempatan yang baik ini saya akan memandu diskusi kita. Jadi saya kira kita akan invite, ada Bu Dewi, ada Pak Arif Rahman untuk juga bisa mereview current construction 4.0 status in Indonesia gitu ya. Karena seringnya terdistorsi hanya sama dengan 3D model gitu ya. Padahal Profesor Mirek tadi sudah bilang sampai ke luar angkasa gitu ya. Nah, apa kira-kira handicapnya dan bagaimana kita bisa melengkapi diskusi tadi pagi agar kita nanti bersama-sama bisa memberikan rekomendasi kepada pemerintah melalui Pak Grimon dan Pak Roshid. Nah, mohon izin, saya akan provok dulu. Mohon izin Bu Dewi. Jadi satu hari ini kita berusaha secara maksimal untuk kita bisa mencatat ya partisipasi publik, saya sebut saja begitu Pak Panani ya, sebagai komunitas konstruksi meskipun masih ada mahasiswa, untuk bisa menghasilkan satu documented recommendation policy gitu, yang nanti kita akan sama-sama refine. Jadi isunya adalah tadi pagi sudah disebut-sebut masalah transforming construction gitu ya. Saya agak kaget juga ya, di banyak negara isu transformasi itu luar biasa. Saya kira Pak Chan tadi juga sudah mengintroduce banyak perspektif di negara-negara lain. Pertanyaannya apakah kita akan adapt atau copy paste atau kita mau berangkat dari our own culture level begitu. Nah, sementara saya nanti dibantu oleh Bu Iris. Mana Bu Iris? Ada di belakang sebagai raportur. Kita punya outline ya. Tagline-nya adalah Human Capital and Leadership Toward Construction 4.0. And I have a special request to Professor Mirek. Could you help us how we can, go through the construction 4.0, not only the 3D printing, but also the issue of, let's say, BIM or let's say the robotics, yeah, in terms of human capital development as well as leaderships, because we need to improve the capacity of our construction industry through construction human capital development as well as the leaderships. Kemudian Bapak sekalian, mari sama-sama kita berkontribusi. Ada 7 bagian, mohon berkenan nanti di acara expert panel, semuanya menjadi expert panel. Hanya kebetulan Bu Dewi sama Pak Arief ini memang kita minta duduk di depan ya. Kita tadi sudah di-advise oleh Pak Tike Chan dengan riset dan dengan Pak Abdu bicara tentang construction industry today. Artinya industri konstruksi Indonesia saat ini itu seperti apa, tadi sudah diceritakan. Kemudian tadi yang belum banyak dibahas adalah construction industry expected. Apa sih yang kita harapkan gitu ya. Apakah we are going to adopt misalnya 3D models ya through extensive research and development. Apa itu gitu ya. Atau kita akan mulai dari mana gitu ya. Kemudian yang penting adalah tadi sudah dielaborasi oleh Pak Rizal, the root problems ya. Saya sebut tadi kalau itu prerequisite saya bilang the root problems. Tapi selalu di-challenge. Lalu solusinya apa gitu ya. Kalau kita masih punya masalah di governance, kita masih punya masalah di transparansi dan sebagainya gitu ya. Tapi yang tidak kalah penting adalah with benefits. Siapa yang menjadi pemanfaat itu siapa kalau bicara construction industry. Tapi kalau tadi kita coba buka lagi presentasi Pak Chan, Pak Tike tadi, ada yang menarik yang menurut saya penting untuk kita underline ya. Kalau bicara konstruksi itu ternyata tidak hanya sama dengan kontraktor. Sebagaimana narrow definition, just an assembly of something on site gitu ya. Tapi merupakan system of production gitu, kira-kira gitu ya. Hanya catatan saya Pak Panani, mohon izin Pak Panani, Pak Rosid, Pak Gimron, kita kalah dengan istilah infrastruktur gitu ya. Jadi sekarang ini politiknya politik infrastruktur, politik konstruksinya menurut saya agak lag behind gitu ya. Yang penting kita punya jalan sekilometer, punya bendung, punya rumah, tapi bagaimana to deliver the best gitu ya Pak ya. Bendung, jalan, jembatan, gedung itu dengan efisien, quality dan sebagainya gitu. Nah, kemudian yang tidak kalah penting adalah the recommended strategic action. Tadi Pak Krisna sudah advice kita bagaimana kita sama-sama mendiskusikan itu, and conclusion. Nah, sementara ini yang ingin saya ajak Bu sekalian untuk berdiskusi. Nah, sekaligus nanti Bu Dewi tadi sudah punya catatan, saya ingin mohon ke bawah Mas untuk memanas-manasi aja, gitu. Nah, pertama kita punya ini Pak. Apakah benar bahwa konstruksi itu menjadi means of improving quality of life misalnya ya, atau economic driver misalnya. Kemudian the future challenge-nya apakah high demand? Ya, termasuk tadi kita mau diajak Pak Mirek juga berpikir kita bagaimana membuat rumah di bulan misalnya atau di Mars gitu ya. Atau kita punya high competition misalnya, atau punya high pressure, cepat misalnya begitu ya. Tapi kita karena isunya banyak sekali yang saya catat tadi, termasuk masalah data, kemudian project owner ignorance gitu ya, project oriented industry dan sebagainya. Terus bawa aja Mas, ini catatan dari pagi. Kemudian industri today itu misalnya market value-nya sampai kepada institusinya dan sebagainya gitu ya. Ke bawah construction and debated. Nah ini saya copy paste aja tadi dari bahan diskusinya Pak Tike gitu ya. Apakah Bapak sekalian oke gitu ya? Untuk kita nanti rekomendasikan kepada pemerintah ya. Bawah lagi Mas. Kemudian isu environmental karena di FTSL Pak Abdu ya, lingkungannya, built environment-nya, isunya gitu ya. Nah, ini tadi punya Pak Rizal catat. Terus baca aja. Nah, yang penting juga siapa yang penerima manfaatnya siapa? Kalau kita talking about construction and development, talking about the construction 4.0, sebenarnya beneficiaries-nya siapa gitu ya? Project owner saja, workers, consultant, engineer, architects, contractor, atau siapa? Atau public secara umum gitu ya. Nah, ini recommended strategic action-nya, catatan kita harus punya industry master plan misalnya. Tetapi yang kalau penting adalah ini saya catat dari Bu Dewi tadi, harus ada think tank for industry policy making-nya gitu. Ini hanya sekedar provokasi, mudah-mudahan Bapak sekalian nanti juga bisa membantu kami untuk bisa mengupdate, memutakhirkan hal-hal yang sekiranya penting untuk kita kontribusikan kepada bangsa dan negara. Baik, saya kira demikian. Saya undang Pak Rahman lebih dulu, mohon izin Bu Dewi. Pak Rahman barangkali bisa memberikan feedback, review, namanya expert panel. Jadi saya undang untuk bisa memberikan tanggapan sekaligus juga hal-hal yang tadi menjadi catatan kita bersama. Kami persilakan Pak Rahman. Ya, mohon izin waktunya 15 menit barangkali ya Pak Rahman ya.
Oke, saya udah dipaksa Pak Aji ya. Terima kasih Pak Aji. Sebenarnya kalau dari sisi industri konstruksinya, kompleksitas industri 4.0 itu hampir sama dengan bidang yang lainnya. Tapi pada kenyataannya bagaimana kita mengimplementasikannya itu yang jadi pertanyaan. Karena kalau kita lihat mungkin Bapak dan Ibu tahu ya, yang udah senior, industri konstruksi kita 5, 8, 10 tahun yang lalu dengan sekarang, kalau kita ke site konstruksi, bedanya apa dengan sekarang? Nggak jauh beda kan? Tapi kalau kita lihat industri manufaktur 5, 10 tahun yang lalu, itu udah beda sama sekali. HP yang kita pakai 5 atau 10 tahun yang lalu itu nggak kepakai sama sekali sekarang. Jadi memang istilahnya keterbelakangan industri konstruksi untuk mengadap teknologi itu bukan sekedar masalah teknologinya aja. Teknologinya itu open, bisa kita adaptasi, tapi kita ada barriernya di sana, yaitu aturan. Kita punya aturan-aturan yang mengikat kita, yang kita nggak bisa begitu fleksibel untuk menerapkan teknologi di lapangan, baik itu dari sisi konstruksinya, dari sisi pelaksanaan, safety dan segala macamnya. Bapak juga pakar safety-nya di sini. Jadi kita terikat akan aturan-aturan ini. Ya, kalau di manufaktur mereka bisa meriset segala macamnya, yang impact-nya hanya untuk produk tersebut. Tapi kalau di kita impact-nya itu banyak. Entah itu lingkungannya, entah itu manusianya, entah itu produknya itu sendiri, itu impact-nya banyak. Jadi misalnya ada failure terhadap konstruksi, pertama yang disalahkan mesti kontraktornya. Jadi kita dianggap yang bertanggung jawab di sana. Jadi karena keterbatasan inilah, maka kita untuk melangkah adopsi teknologi itu juga istilahnya hati-hati sekali, Pak. Jadi kehati-hatian ini yang mengakibatkan kelambatan industri konstruksi untuk mengadopsi teknologi yang ada sekarang. Nah, itu yang menjadi masalah. Jadi kan kitanya nggak mau mengadopsi industri industri 4.0, tapi aturan-aturan yang ada itu menjadikan barrier kita untuk menerapkan konstruksi secara digital dan lainnya. Di lain hal, kita juga seperti yang dikatakan tadi dipresentasikan masalah 3D printing. Sebenarnya saya belum diizinkan untuk mengekspos 3D printing secara company. Tapi gini, 3D printing itu kalau di kita sudah melakukan riset. Cuman kita sampai meriset ke mana, ke Abu Dhabi dan segala macam. Kita ngelihat skala produksinya 1:1 di sana. Tapi begitu kita bandingkan output dan printing, contohnya kekuatan dindingnya itu kalau kita ukur itu sampai 145 MPa. Kemudian kita bandingkan, kita dapat penugasan dari pemerintah untuk membangun low cost housing. Low cost housing itu kekuatan dinding bata ringan itu paling cuma 20-25 MPa. Nggak bisa dibandingkan dengan 3D printing. Otomatis cost harga satuannya itu per meter persegi itu nggak akan bisa kita ketemu dengan 3D printing sekarang ini. Kecuali ada inovasi material tertentu. Ya, kalau kita pertemukan antara misalnya konkret 3D printing dengan rumah bata ringan di Indonesia, itu cost satuannya itu nggak akan bisa kita lawan. Tetap akan jauh lebih murah harga satuan dari rumah bata ringan itu tadi. Jadi bukan masalah kita nggak mau menerapkan ini, cuman secara ekonomis itu juga belum bisa diterapkan secara massal. Jadi masih dalam skala riset dan skala uji coba lah. Nah, ini yang menjadi barrier-barrier kita di samping skala aturan-aturannya, skala ekonomisnya. Karena best practice sendiri, margin dari konstruksi itu nggak besar, Pak. Margin dari konstruksi itu plus minus 3-6%. Jadi bayangkan kalau kita melakukan uji coba yang itu menyebabkan kegagalan, habis seluruh margin dari konstruksi ini tadi. Jadi saya pikir teman-teman di sini bisa dipahami. Jadi bukan industrinya yang nggak mau melakukan, tetapi karena barrier-barrier itu yang menyebabkan lag di industrinya. Saya kira segitu.
Luar biasa, kita akan berus untuk Pak Rahman. Ya, Bu Dewi, please, it's your turn.
Terima kasih Pak Haji. Sebelumnya saya itu dulu ya Pak ya. Ini mendadak ya Pak Krisna ya. Baru setengah 15 menit yang lalu. Saya diminta ke depan. Tapi saya berterima kasih juga diberi kesempatan untuk sharing atau diskusi dengan Bapak Ibu yang ada di sini terkait dengan isu IT ke depan di industri ini. Kalau menurut saya ini adalah keniscayaan. Mau tidak mau kita harus transformasi juga diikuti dengan penggunaan IT dalam industri ini. Itu sudah sebuah yang bagaimanapun kalau saya melihat bahwa karakter industri ini sudah disebutkan Pak Haji sebagai akar masalah dari segala ketidaksesuaian begitu. Jadi karakternya fragmented, multi stakeholder, high risk, under uncertainty tadi, tidak di bawah ketidakpastian yang begitu besar begitu. Jadi otomatis menurut saya yang bisa menyelesaikan sebagiannya adalah IT. Bagaimana kita berkolaborasi, ternyata gagal terus. Kolaborasi yang fragmented ini sudah menjadi darah daging. Salah satu yang membuat kita bisa berkolaborasi adalah platform. Pasti dengan itu kita bisa bicara dengan lebih cepat, lebih mudah, nggak include data dan lain sebagainya gitu. Maksudnya data tidak dikejar satu karena semua orang bicara pada tempat yang sama dengan data yang sama. Jadi artinya bahwa dia sebagai enabler, dia membantu kita untuk memperbaiki beberapa masalah yang sebetulnya susah sekali kita selesaikan di industri ini begitu. Jadi termasuk yang tadinya pentahapan kita bisa kejar lebih cepat. Jadi orang lain sudah punya data sebelum dia nggak mesti menunggu selesainya satu tahap ke tahap yang lain. Dia sudah mendapat informasi lebih awal. Artinya keterlibatan lebih awal semua stakeholder itu bisa terjadi, sehingga otomatis beberapa risiko bisa diskusikan lebih awal, kita identifikasikan, kita dan lain sebagainya. Jadi bagaimanapun IT bisa membantu kita menyelesaikan beberapa masalah, meskipun tidak semua masalah, termasuk tadi kepercayaan. Kalau kata Pak Krisna, kalau sudah terbuka semua data, ya nggak ada lagi yang curi-curi. Kita beri keuntungan 10% nggak ada masalah. Yang penting atau 15% atau 20% kepada PP atau OS kita sekarang Pak. Itu nggak ada masalah. Yang penting kinerja mereka 5 kali lipat dari yang kita harapkan. Edit value-nya 5 kali. Kenapa? Daripada tadi nggak dapat edit value, harganya murah-murah, tapi kita nggak punya edit value apa-apa. Nah, ini meningkatkan kepercayaan satu sama lain karena kita bisa buka-bukaan. Kita sampai sekarang misalnya sulit sekali ngitung volume grading dengan IT, mulai dari class action kita lihat. Pokoknya segala susah bisa dengan mudah kita identifikasi begitu. Jadi kalau menurut saya otomatis ini sebuah keniscayaan bahwa kita ke depan harus menggunakan IT di industri ini. Itu di satu sisi. Di sisi lain ya tadi kita punya banyak keterbatasan, sehingga barangkali IT juga membantu kita dalam hal memanfaatkan resource lebih efisien. Itu harapan kita sebetulnya. Jadi termasuk tadi kalau kita bicara prefabrikasi, 3D printing adalah satu bagian barangkali diawali dengan prefabrikasi yang kemudian nanti akan mengarah kepada 3D printing. Jadi bagaimanapun itu juga salah satu cara kita untuk kita bisa berubah, bertransformasi. Jadi tidak semua insight yang penuh risiko, in situ yang penuh risiko, ada sebagian yang kita sudah lakukan dengan produksi yang lebih dekat dengan manufaktur gitu. Jadi ada beberapa hal yang kita, karena manufaktur lebih tinggi kepastiannya daripada in situ gitu. Jadi atau insight construct, otomatis beberapa risiko bisa kita kurangi ketika kita mencoba membawa sebagian meskipun tidak semua dari industri ini ke manufaktur. Jadi industri manufaktur konstruksi merupakan juga salah satu yang kita perlu dorong kalau kita mau meningkatkan, memperbaiki kinerja dari industri ini atau mau lebih depan. Dan ketika kita bicara manufaktur, otomatis kita bicara teknologi di industri ini. Nah, bagaimana 3D printing? Ya banyak masalah juga. Misalnya kalau Pak Krisna titip ini gimana dengan padat karya? Kalau sudah di printer kita nggak bisa lagi bicara padat karya. Padahal bonus demografinya masih besar. Kalau Cina mungkin kehilangan demografi sebentar lagi. Jepang, Eropa kehilangan bonus demografi. Kita masih dalam waktu 25 tahun ke depan mungkin masih beruntung dengan bonus demografi otomatis. Tapi saya bilang ke depan nggak ada anak-anak yang mau lagi jadi tukang atau jadi lapangan karena semua mau jadi YouTuber. Nggak ada lagi, otomatis nggak ada yang mau jadi tukang batu, nggak mau ada yang jadi semua tukang tadi yang tukang gali atau yang membuat dinding udah nggak ada lagi karena semua anak-anak nggak ada yang mau, udah upahnya kecil, kerjanya keras, salarinya nggak naik-naik. Tadi sudah sebagai dasar ya, otomatis kita perlu juga pengganti karena kalau engineers kita tetap perlu. Tapi tadi kalau yang bawah itu kemungkinan harus memang harus kita gantikan dengan mesin begitu Pak. Jadi otomatis isu bahwa di 3D printing juga akan kita manfaatkan adalah satu yang perlu kita pertimbangkan untuk menjadi bagian penelitian di riset-riset di konstruksi. Barangkali itu Pak.
Baik, luar biasa, kita berikan aplaus untuk Bu Dewi. Saya kira beliau berdua dan Prof. Mirek sudah memanaskan diskusi kita. Tapi catatan yang menarik tadi dari Pak Rahman ini, industry players, menyebut-nyebut bicara tentang barrier to transform our industry to, let's say, construction 4.0. Ya, salah satunya bicara tentang aturan, betul ya Pak? Di samping juga skala ekonomi gitu. Nah, saya akan beri kesempatan lebih dulu ke Pak Kimron dan Pak Rosid, Pak. Ini ada catatan yang menarik dari industrinya. Paralel pemerintah sedang merancang omnibus law gitu ya. Apa kira-kira yang bisa direspon Pak Kimron dan Pak Rosid? Beliau berdua akan saya minta reviewnya. Monggo Pak Kimron.
Terima kasih Pak Haji. Terkait dengan konstruksi 4.0, sebenarnya Kementerian PUPR sudah mencoba aktif lah ya di dalam implementasi 4.0, dan memang kami akuin ya agak lambat lah meresponnya karena ketika kita mau coba implementasikan perkembangan cepat sekali gitu. Jadi bingung juga mau mendalami yang ini versi berapa, belum selesai udah lompat lagi. Jadi tapi namun demikian kami mencoba secara menyeluruh dengan aspek-aspek yang di PU untuk bisa menerapkan 4.0 ini. Intinya kegiatan-kegiatan kita yang sudah mencoba ya mengapakan teknologi ini, pertama masalah big data. Karena terus terang di dalam 4.0 ini yang paling penting berperan adalah juga big data. Jadi kita mencoba sekarang membuat suatu unit di Kementerian PUPR yang mengumpulkan semua data-data yang terkait kegiatan konstruksi di PUPR. Kemudian penerapan BIM. Nah, ini juga kita agak malu juga ya karena kita baru tahap-tahap uji coba. Regulasi yang agak menyinggung BIM baru dicipta karya ketika ada pembangunan suatu gedung skala tertentu, itu pun untuk perencanaannya gitu ya. Jadi
masih jauh lah. Seharusnya all project cycle itu bisa menggunakan BIM seperti itu. Kemudian kita ada sering mengadakan seminar atau apa, kegiatan-kegiatan BIM ini, tapi juga belum optimal. Namun pemerintah saat ini memang pertama PUPR concern. Jadi umpamanya kayak penanggulangan banjir, perencanaan bendung dan sebagainya, itu kita sudah mencoba nanti menggunakan teknologi BIM. Satu hal yang agak terbantu PUPR, mitranya yang dari penyedia jasa, teman-teman dari kontraktor terutama yang BUMN, udah voluntary mengadakan sendiri gitu ya riset-risetnya. Jadi terbantu juga. Jadi ini kita belajar dari anaknya gitu. Nah, tapi itulah kenyataan yang ada. Tapi ini memacu kita ke depan supaya di level pemerintah juga harus cepat tanggap. Karena kalau tidak, kita akan selalu tertinggal. Dan suatu lompatan yang pasti dengan 4.0 ini, semua praktek atau proses bisnis jasa konstruksi itu bisa diperbaiki semua, mulai dari hulu sampai hilir gitu. Misalkan kami dalam proses lelang sekarang, mungkin akan mengedepankan masalah database, sehingga kita nggak perlu lelang yang konvensional, mungkin kita sudah bisa lelang pakai IT gitu ya, dengan sikap atau raportnya masing-masing kontraktor konsultan maupun tenaga ahli itu masuk ke dalam big data, sehingga kita lelang, panitia itu nggak harus ngejar yang data-data yang sudah ada, harus dicari lagi gitu. Yang dimana dalam prakteknya ini terkadang terjadi bias gitu ya, orang nggak punya pengalaman ABC bisa jadi seakan-akan pengalaman ABC. Dan ini sesuatu yang konyol gitu, di zaman sekarang orang nggak tahu seseorang itu backgroundnya apa, pekerjaannya apa yang sudah dilakukan. Padahal data itu ada di mana-mana sebenarnya. Itu contohnya Pak. Kemudian untuk proses-proses seperti tadi di sambutan pengawasan, salah satu titik lemah pekerjaan-pekerjaan di Kementerian PUPR itu adalah di tingkat pengawasan, supervisi. Nah, jadi kalau kita bedah, banyak alasan klasiknya dananya sangat marginal sekali untuk bisa menempatkan seorang supervisi yang baik di sepanjang proyek tersebut. Mungkin dengan 4.0 ini kita bisa terobosan, katakanlah kayak sistem CCTV tadi, CCTV yang bisa membaca kejadian yang ada di suatu proyek. Itu juga kita nggak perlu apakan orang sebanyak di lapangan, atau juga melalui teknologi drone, kamera video drone itu bisa juga untuk daerah-daerah yang susah dijangkau. Saya kira prinsipnya kita dari sisi rencana pengimplementasiannya sangat tinggi sekali. Dan satu yang ekstrim juga terjadi di PU, pembubaran leadbanknya. Nah, mungkin sudah dicatat leadbank ini memang banyak berbuat, tapi kayaknya nggak merespon kepada perkembangan yang terjadi. Selalu terjadi di belakang gitu, terlambat satu langkah. Jadi kita kementerian membubarkan, tapi substansinya itu dikembalikan ke masing-masing unornya. Jadi Bina Marga punya unit direct yang lead bank. Jadi apa kebutuhan dia langsung yang mengadakan kegiatan research-nya gitu, sesuai dengan kebutuhannya. Dulu ya ada semacam pameo bahwa researcher kami di lead bank hanya memuaskan diri sendiri gitu. Jadi mencari kreditnya itu mencari judul yang nyaman di dia, bukan menjawab apa kebutuhan Kementerian PUPR. Tapi ini sekalian juga saya men-challenge di Construction Engineering Management Research Group ini, karena kalau saya lihat happy-nya ini banyak juga bersinggungan dengan kami di Kementerian PUPR, terutama di Bina Konstruksi. Tolonglah kita kalau bisa ke depan saling komunikasi lagi. Saya berharap apa yang diproduk teman-teman S2, S3 di sini itu bisa juga menjawab challenge yang ada di kami gitu. Jadi hasilnya itu nanti bisa digunakan. Dan dengan adanya nanti permintaan request data apa yang dibutuhkan teman-teman S2, S3 di sini, maka kami nanti di PU bisa menyiapkan perangkatnya. Jadi kita itu kan sekarang banyak research itu miskin data gitu ya, karena susahnya akses mengambil data-data series, konstruksi, kejadian, apalah gitu ya. Nah, kalau memang ada komunikasi itu kita sudah siapkan template-nya, berarti setiap proyek PU mulai dari perencanaan sampai nanti demolisnya atau terakhirnya, itu nanti bisa terdata dengan baik, dan mahasiswa bisa mengambil mau data apa aja gitu. Data kejadian kecelakaan, data biaya proyek, gagal lelang, dan segala macam yang terkait dengan construction engineering management tersebut. Mungkin itu yang bisa kami tawarkan, Pak. Terima kasih.
Terima kasih, Pak Bimo. Silakan, Pak Rosid. Tadi isunya, kalau boleh saya catat, Pak, overly regulated. Kemudian juga menjadi barrier Pak untuk innovation bahkan untuk construction 4.0. Monggo Pak Rosid, catatannya apa Pak?
Baik, terima kasih Pak Haji. Bapak Ibu yang kami hormati, terkait dengan regulasi yang tumpang tindih, kita sekarang sedang menyusun undang-undang omnibus ya, yang sebetulnya bukan yang pertama kali kita melakukan omnibus ya. Sebetulnya tahun lalu sudah ada peraturan perundangan yang sebetulnya itu juga termasuk omnibus, yaitu PP 24 tentang OSS ya, di mana dengan OSS itu maka proses perizinan menjadi lebih mudah, lebih transparan, walaupun tidak seindah namanya gitu ya. Di dalam implementasinya banyak persoalan karena penyusunannya mungkin yang tergesa-gesa gitu ya. Satu itu. Nah, kedua, dengan sekarang sedang disusun 2 undang-undang baru yang salah satunya terkait dengan PUPR, ada 6 undang-undang yang terkena omnibus itu ya. Yang pertama adalah undang-undang bangunan gedung, undang-undang perumahan dan kawasan permukiman, undang-undang jalan, kemudian undang-undang jasa konstruksi, undang-undang arsitek, kemudian udah ya apa? SDA ya, SDA. Nah, yang pertama di dalam proses omnibus ini prinsip dasarnya adalah pengaturan kewenangan gitu ya. Jadi kalau selama ini di dalam undang-undang itu ada tabrak-tabrakan ya, amanat bahwa kewenangan pemerintah, kewenangan provinsi misalnya itu langsung disebut di situ, sehingga kemudian juga kewenangan Kementerian Teknis misalnya begitu. Nah, sehingga dengan omnibus ini akan ditata ulang gitu ya. PR kita adalah di dalam penyusunan PP-nya gitu. Karena dalam undang-undangnya